All right, well, we're going to start with our discussion of OLS regression, and this time we're going to focus on a very, very practical, applied understanding of OLS regression in Stata, okay? So, using Stata to estimate an OLS regression. Now, keep in mind, whenever we're doing an OLS regression, we have a dependent variable that is continuous, right? So it uses the full scale of the number, the full length of that number scale. In this case, we're going to use the house data set, and we're going to ask a very simple question about whether or not income and incumbency has had an effect on Democratic presidential vote shares in 1996. Okay, there are two ways to do this. First, we can type in the Stata command line. Once you've opened up Stata, you can type in regress, followed by a space, the dependent variable, another space, and then you're going to list the independent variables in your model. The other way you can do this is by using the drop-down menu, by scrolling to the top of Stata and picking statistics, then linear models and related, then linear regression. Once you pick linear regression, you're going to get a bunch of drop-down boxes where you can enter the dependent variable and the independent variables in the appropriate spaces, and it will then generate your regression model. Okay, so how do you interpret the results of this particular equation? First of all, with that first question, how much am I explaining here? You're going to first look at the goodness of fit measure. In this case, that goodness of fit measure is called an R squared, and you'll see it on the far right-hand side, just above that, well, right next to where it says number of observations. You're going to look all the way down that little column to find R squared. That R squared is always interpreted as a percentage. It's very, very similar to eta squared, which we talked about when we were talking about analysis of variance. Second big question is my pet variable significant? How did my hypotheses fare? First thing you want to do is check your beta coefficients, right? That's the slope of your regression line. So see the column, look for the column labeled coef, right? That's short for coefficient. That's going to give you the actual beta coefficient for each independent variable. Then you want to know whether or not your independent variable is, or your coefficient is positively or negatively signed. So is the relationship between that variable and the dependent variable positive or negative, right? And ask yourself, does it fit your hypothesis? Next, you want to scroll across to the significance. So you're going to see a couple different columns. The first column is coefficient, second column standard error. There's a third column there. Just past that third column, that fourth column is your level of statistical significance. As a rule of thumb, if your p-value is less than 0.05, then you have statistical significance. That's how you read that column right there. The final thing you might want to look at is what is the intercept term for this regression line. In this case, we're going to look for the variable labeled underscore cons, which is short for constant. So let's do a quick recap here. So how much am I explaining? In this case, as you'll see over at the R squared, it's 0.3462. So in this case, we would say 34.62% of the variation in my dependent variable, in this case dp96, is explained by all of the variables in my model. Next big question, is my pet variable significant? How did my hypotheses fare? First, check the beta coefficients. Is the coefficient positive or negative? Let's say we're primarily interested in income, right? In this case, income is positively signed, so I can say that the relationship between income and dp96 is positive. Now, if I had a hypothesis that suggested that they would be positive, then I've got some reason for hope here. Second thing I want to do is I want to find out whether or not that coefficient is statistically significant. If I scroll across to that p-value column, I will see that income gets a p-value of 0.096, so it's not statistically significant. Sad face. Finally, where is the intercept? In this case, my constant term, or my intercept, is 0.5620. Now, I'm not going to do anything with that right now. We'll get to that next time. but that will help me draw my regression line later. All right, so next time what we're going to do is we're going to talk about how to interpret those beta coefficients. What is the impact on the dependent variable? And so that'll be our next lecture. Just as a little hint to you, there are ways in which to interpret these coefficients that make you sound either like a red-shirted human from Star Trek. For those of you who are familiar with this particular show, that means your lifespan is short. Secondly, you have ways to interpret these coefficients that make you sound like Spock from Star Trek. And finally, there are ways in which you can interpret these coefficients that make you sound like a really smart political scientist who likes to talk to other humans. The choice is yours.